In this question, it says, given that sine A is minus 3 over 5, and that A is greater than 180, but less than 270, and that cos B is equal to minus 12/13, and B is obtuse, find the value of cos A minus B. So what we need to do first of all is work out the value of cosine A, and we can use the standard identity that sine squared A plus cos squared A is identical to 1. Therefore we can say that cos squared A is 1 minus sine squared A, so we can say that's the same as 1 minus 3 over 5 squared, which is going to be 1 minus 9 over 25. Don't forget minus 3 over 5 is positive 25 if you square the result, but because you've got a minus on the outside, that's why we get a minus 9 over 25 for clarity. So we could write that as 25 over 25 minus 9 over 25, and we can say from there that cos squared A is equal to 25 minus 9, which is going to be 16. So it's going to be 16 over 25. And then don't forget, when we square root this result, we get a plus or a minus. So root 16 over 25, that's going to give me plus or minus 4 over 5. So what the issue here is we don't know whether it's a positive result or a negative result, but this is the beauty of the cast diagram. So if we were to draw a cast diagram here and say ASTC, we know that the result is greater than 180 but less than 270, which means that the result lies in this quadrant, the third quadrant. And we can say, since cosine is negative in the third quadrant, we can conclude that cos A must be minus 4/5. So therefore, cos A is minus 4 over 5. Now we need to go back to the question, and it says that cosine of B is minus 12 over 13, and B is obtuse. We need to work out what sine B is. So if B is obtuse, so we can say, if we were to draw an obtuse angle like so, and say ASTC by the cast diagram, we know that sine is positive in the second quadrant. So sine is positive in the second quadrant. So we can say sine squared A, or in our case, sorry, B, is 1 minus cos squared B. So it's going to be 1 minus what we've got here, minus 12 over 13 squared. So that's going to give me 1 minus 144 over 169, which is the same thing as 169 over 169 minus 144 over 169. So we can say that's the same thing as 25 over 169. So sine squared B is exactly the same as 25 over 169. So when we square root, don't forget we always get a positive and a negative result. So if we square root this whole thing, so sine B is plus or minus 5 over 13. Now we need to put this into the result of cos A minus B, but before that we need to say that because sine B is positive, it's going to be positive 5 over 13. So we can now write the formula out for cos A minus B, which is cos A cos B plus sine A sine B. So now we can write in our values. So we know that the value for cos A we worked out was minus 4/5. Just write that in. And we know that the value for cos B, they've told us, is minus 12 over 13. We know that sine A is minus 3 over 5. And we just worked out sine B, which is positive 5 over 13. And if we were to do that on your calculator, you will get 33 over 65. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So, given that sine A is 8 over 17, where A is an acute angle and cos B is minus 4/5, where B is an obtuse angle, find the value of sine A minus B. Well, the first thing we ought to do is to work out cos A. So we can say cos squared A is 1 minus sine squared A, which is 1 minus 8 over 17 squared. And that's going to give me 225 over 289. So cos squared A is that. So cos A is plus or minus the square root of all of that, which will give me cos A is equal to plus or minus 15 over 17. But if we go back to the question, originally they told us that A is acute, so all angles are positive in the first quadrant. So we can say all angles are positive in the first quadrant, so therefore cosine of A must be positive 15 over 17. Now we know that B is obtuse and cos B is minus 4/5, so we need to find sine B. So we can say sine B, or sine squared B, is 1 minus cos squared B. So in our case, we can do 1 minus 4/5 all squared. So sine squared B. So we can work this out. So that works out to be 9 over 25. So when we take the square root of that, it's got to be plus or minus. So it's going to be sine B. Sorry for my lack of clarity there. Is plus or minus, well, the square root of 9 is 3, square root of 25 is 5. But they've said that B is obtuse, and we said in a previous example that the obtuse angle looks like that, and sine is positive in the second quadrant. So since sine is positive in the second quadrant, we can conclude that sine B must be positive 3/5. And what we're trying to work out is the value of sine A minus B. So we can say that sine A minus B is sine A cos B minus cos A sine B. So we can say that sine A, we know, is A over 17. Now cos B is, we said, was minus 4/5. Minus cos A, which is 15 over 17. Times 17 properly. Sine B, and that's 3/5. So we can type that into our calculator and write down the result. And that works out to be minus 77 over 85.